So in this video here, we're going to learn the simple step in graphing for the functions, square root functions, where we have the square root function in the form of fx equals to a multiplied square root of mx plus c plus k, where the capital A is referred to a constant that is not equal to 0, so do the m. So let's see. So basically, I will split it into 5 steps here when the time we do sketching for this graph here, where the first one is the type of the function, followed by the shape, the special points or line, the intersections on x and y axis, and then at last we go graphing. And let's just go through on the details on each of this type here, each of this step here, before I go on with the example on the sketching. So first, step 1. You will need to refer what is the thing that I mean by the type of functions. So first of all, the square root functions that I refer here, the type that I refer here is I have the form of a constant a multiplied with our square root, where the content inside the square root, as you can see here, is happen to be a linear function mx plus c, and then plus with another constant. This constant k here, it can be happen to be 0, positive or negative answer, and the a here mainly is referring to the sign that we have for the square root functions. So for examples, this is some of the form that fulfill the requirement in this case here, where we have square root of a linear functions. So 3x plus 2, square root of 3x plus 2, square root of 4x, square root of 3 minus 5x, square root of 1 over 2x, square root of x minus 1. And then the square root happen to multiply with a constant. So in this case here, the first one is multiply with positive 1, multiply with negative 1, multiply with positive 1, multiply with positive 1, multiply with positive 2. And then the corresponding constant k will be negative 5, positive 3, 0, 0, 7. And the summary, it can be seen from this table here, where the corresponding a, m, and c, k correspond to the form that we have in the formula. Next, after we understand the type of functions that I mentioned in step 1 here, let us see step 2, that we want to identify the shape of the function that we have. If let's say I have the form of function in the form of a square root of mx plus c plus k, then in general, the shape of the graph that I have is that I can have the shape in the form of a parabolic curve that we happen to cut into half, which means that this is what happening, where a parabolic curve in this form here, but I would like to just have half of it, which means that again, this is my parabolic curve. I just want to have half of it, the part that I highlighted. So it can be the upper half or the lower half. So the shape that you need to recognize here is that first, if let's say you have the square root happen to be positive, the square root happen to be positive square root, the coefficient of x is happen to be positive x, which corresponding to the a is positive greater than 0 and the m is positive greater than 0, then the shape of the graph will look something like this. And some of the examples that we can have: y equal to square root of x, y equal to square root of 4x plus 1 plus 3, 2 times of square root of x plus 1 plus 3. Where once again you can see here, for positive square root, so your square root is positive, then followed by your x is positive. The x comes with positive coefficients. Then beside the shape of the graph, what will happen is that, let's say, if I consider instead of having of positive x, I have the case of negative x, but come with positive square roots, what will happen is that you'll find out that we have the shape of the graph happen to be flipped horizontally, and this is happen to be the case where I'm going to have positive square roots, negative x. So you find out that I try to switch the sign on the x. So if I switch the sign for the x, I need to flick horizontally. The idea here, you must take notes. And therefore, these are the examples that you can see. I switch the sign on the x. From positive x, I switch to negative. The square root is still maintained as positive square root. So now you see the shape of the graph. I happen to flick horizontally. Whereas, if let's say I do another changes, if let's say I happens to, from this one, positive square root and positive x, I happen to do the changes in such way that I maintain with positive x, I switch to negative square root. Then what I need to do is that I need to, from this graph here, the changes is on the square root, from positive become negative square root. So I need to flick it vertically. And it will give me this result. And the examples, as you can see here, each of this function here, I switch the square root become negative. So this is the shape that I have, where I have positive x, negative square root, which corresponding to a less than 0, m greater than 0. Follow? Lastly, if let's say I continue from the graph that I have resultant from these two, if let's say I continue by switching the sign, where let's say positive x, negative square root of negative square root, I switch from here, I want to switch to negative x, maintain square root of negative square root. So in this case here, kalau I refer from on top here, on top of this case here, is that I'm switching from positive sign of square root become negative sign. And what is the changes happen? Let's see. So in this case here, I'm going to change the positive square root become negative square root. So I need to flick it vertically. And from this positive x change to negative x, I will happen to need to flick it horizontally. And both of these will come up with the result that this is the shape of the graph. Well, in this case here, I have negative x, negative square root, which corresponding to the a is less than 0, m is less than 0 in here. And these are the example as you can see. I switch the square root, I switch the x accordingly. So basically this is the 4 shape of graph that I want you to take notes. And by right, you just need to remember this one. By the time you have positive function of square root, positive x, and then the rest, you just remember the rules how to flick either left, right, or up, down to get the shape. Next, step 3. We want to know the special point inside these functions here. So the special point is referring to the vertex. The vertex, if you refer to this point here, which is, if let's say I have a full quadratic curve, this is the point I'm referring to. So, therefore, how do I get the coordinate of this vertex here? It's very important to know this special point here, where what does this point happen to tell us if you know this point here is that it's able to tell us that whether the x and y intercept in the next part there, whether exists or not. Kalau tak exist, kita tak payah kira. Then also, it can also from this step here, we determine the domain and range of the graph. Without finishing the complete graph out, start until this step here, we can get the answer for the domain and range. So, continue. So, this happens to the examples that I happens to find out the vertices, where how I get the vertices is that again, I'm referring to the mx plus c there, I'm referring to the mx plus c in the questions there, in the functions there, to find out what is happens to be the coordinate of x. So all this coordinate of x, I obtain based on, I'm making this mx plus c here equals to 0. So this is the corresponding x answer that I solve. Whereas the y coordinates for the vertex is just referred to the constant k. So the constant k I have here, if you happen to refer, is just refer to this constant that I highlighted in green. For those that doesn't see any constant, that means it's referred to plus 0 lah. So you see 0 there. So this is how we get the answer. Then step 4, we would like to decide the interceptions on y and x axis. So this is how we happen to have our answer, where determine y-axis we base on by substituting x equal to 0 inside the function. Determine x-intercept, we substitute y equals to 0, or we say the function fx equals to 0. Usually I will suggest that this one we solve using calculator so that it will be faster. And then at last, we sketch the graph. In the coordinate axis, and make sure you label the xy axis, label the origin, label the graph, label the vertex, and label the xy intercept. In here, the origin is referred to this point here. Just label as 0 to refer to this origin. Label the graph. Let's say the graph is called as fx. Therefore, after you sketch the graph, please kindly label the f there. So this is the label of graph that require. And therefore next, we shall continue with the example.